Electrical non-metallic tubing, or ENT, can be installed in a gravel base under a slab according to the National Electrical Code, or NEC, but specific conditions must be followed. It is important to understand these requirements to ensure a safe and code-compliant installation. The NEC stipulates that if ENT is used in this manner, it must be installed within a raceway that is specifically approved for this purpose. A raceway is essentially an enclosed channel designed to hold and protect electrical wires or cables. Common examples include conduits, tubing, and other similar structures. The purpose of using an approved raceway is to provide a protective barrier for the ENT, shielding it from potential physical damage and environmental factors. The chosen raceway must also be adequately protective from physical damage. This protection can be achieved through various methods, such as using a cover or other suitable means to guard the raceway against impacts or abrasions. The goal is to prevent any damage to the raceway itself, which could compromise the integrity of the ENT and the electrical conductors within. It's crucial to ensure that the raceway is not subject to direct earth burial. Direct earth burial means that the raceway is directly in contact with the soil without any intervening protective layers or structures. This is prohibited for ENT because direct contact with the earth can expose the raceway to moisture, chemicals, and physical stresses that could damage it over time. In summary, for ENT to be installed in a gravel base under a slab, these three conditions must be met. Firstly, the ENT must be installed in a raceway that is approved for the specific application. Secondly, the raceway must be protected from physical damage through the use of a cover or other appropriate means. Thirdly, the raceway must not be subject to direct earth burial. Provided these conditions are met, the NEC permits the installation of ENT in a gravel base under a slab. It's always recommended to consult the latest edition of the NEC and local electrical codes for specific requirements and to ensure compliance with all applicable regulations. When selecting a raceway for this application, consider factors such as the size and number of conductors to be installed, the environmental conditions, and the potential for physical damage. Common raceway options include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and rigid polyvinyl chloride conduit, or PVC. Each type of raceway has its own advantages and disadvantages in terms of cost, durability, and ease of installation. The protection of the raceway from physical damage can be achieved through various methods depending on the specific circumstances of the installation. If the raceway is located in an area where it is likely to be struck by vehicles or other heavy objects, it may be necessary to install a concrete barrier or other protective structure. In less demanding environments, a simple cover or shield may be sufficient. It's also important to ensure that the gravel base itself is properly compacted and graded to provide a stable and even surface for the raceway. This will help to prevent the raceway from settling or shifting over time, which could potentially damage the ENT or the conductors within. The prohibition of direct earth burial for ENT is primarily due to the potential for moisture and chemicals in the soil to degrade the material over time. ENT is typically made of PVC or other non-metallic materials, which can be susceptible to damage from prolonged exposure to these elements. In addition, direct earth burial can subject the raceway to physical stresses from soil movement and settling, which could also compromise its integrity. Therefore, it's essential to ensure that the raceway is adequately protected from direct contact with the earth. This can be achieved by installing it on a gravel bed, encasing it in concrete, or using other approved methods. When installing ENT in a gravel base under a slab, it's also important to consider the potential for condensation to form inside the raceway. Condensation can occur when warm, moist air comes into contact with a cooler surface such as the inside of the raceway. This can lead to the accumulation of water inside the raceway, which could potentially damage the conductors or other electrical components. To prevent condensation, it's important to properly seal the raceway and to provide adequate ventilation. This can be achieved by using weatherproof fittings and connectors and by installing vents at strategic locations along the raceway. In addition to the NEC requirements, it's also important to comply with all applicable local electrical codes and regulations. Local codes may have more stringent requirements or specific provisions for ENT installations in certain areas. It's always recommended to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. The proper installation of ENT in a gravel base under a slab is crucial for ensuring the safety and reliability of the electrical system. By following the NEC requirements and adhering to best practices, you can create a durable and code-compliant installation that will provide years of trouble-free service. Remember to always energize the circuit before working on any electrical equipment and to take all necessary safety precautions. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. The NEC provides specific guidelines regarding the types of raceways that are approved for use with ENT in various applications. These guidelines are intended to ensure that the chosen raceway is suitable for the environmental conditions and the potential for physical damage. For example, rigid metal conduit is generally considered to be the most durable type of raceway and is often required in areas where there is a high risk of physical damage. Electrical metallic tubing, or ENT, is a lighter weight option that is suitable for use in less demanding environments. PVC conduit is a non-metallic option that is resistant to corrosion and is often used in underground or wet locations. The choice of raceway will depend on the specific requirements of the installation and the applicable codes and regulations. The NEC also specifies the minimum size of raceway that is permitted for use with ENT. The size of the raceway must be large enough to accommodate the number and size of conductors to be installed, as well as any necessary bonding conductors. It's important to consult the NEC tables and calculations to determine the appropriate raceway size for a given installation. Using a raceway that is too small can result in overheating of the conductors and can create a safety hazard. In addition to the size and type of raceway, the NEC also specifies the requirements for supporting and securing the raceway. The raceway must be properly supported to prevent it from sagging or shifting over time. The supports must be spaced at intervals that are appropriate for the type of raceway and the weight of the conductors. The raceway must also be securely fastened to the supporting structure to prevent it from being dislodged by vibration or other forces. Proper support and securement are essential for ensuring the long-term reliability of the installation. The NEC also addresses the issue of grounding and bonding for ENT installations. Grounding and bonding are essential for providing a safe path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The NEC requires that all metal parts of the electrical system, including the raceway, be properly grounded and bonded. This can be achieved by connecting the metal parts to a grounding electrode system, such as a ground rod or a water pipe. The grounding and bonding conductors must be sized appropriately for the size of the circuit and must be installed in accordance with the NEC requirements. The NEC also provides guidelines for the installation of ENT in hazardous locations, such as areas where flammable gases or vapors are present. In hazardous locations, it's essential to use explosion-proof or intrinsically safe wiring methods to prevent the ignition of flammable substances. The NEC specifies the types of raceways, fittings, and equipment that are permitted for use in hazardous locations. It's important to consult the NEC and to work with a qualified electrician to ensure that the installation is safe and code compliant. When installing ENT in a gravel base under a slab, it's also important to consider the potential for the slab to crack or shift over time. Cracks in the slab can create pathways for moisture to enter the raceway, which can damage the conductors or other electrical components. To prevent this, it's important to properly prepare the substrate and to use a high-quality concrete mix. It's also important to install expansion joints in the slab to allow for movement without cracking. In addition to the technical aspects of the installation, it's also important to consider the aesthetic appearance of the finished product. The raceway and fittings should be installed in a neat and workmanlike manner, and they should be concealed as much as possible. The use of colored raceway or fittings can also help to blend the installation with the surrounding environment. Ultimately, the goal is to create an installation that is both functional and aesthetically pleasing. The proper installation of ENT in a gravel base under a slab requires careful planning, attention to detail, and a thorough understanding of the NEC and local electrical codes. By following the guidelines outlined in this discussion and consulting with qualified professionals, you can create a safe, reliable, and code-compliant installation that will provide years of trouble-free service. Remember to always prioritize safety and to take all necessary precautions when working with electricity.